Every year, the U.S. federal government generates millions of procurement records, a massive, fragmented avalanche of disjointed text and data. This slide captures the exact scale of that ecosystem, over 161.8 million registered source records, spread across 22 active federal data corpora. We are looking at 74.3 million prime award actions, over 42 million grant awards, and nearly 8 million open contract opportunities. As this slide highlights, making sense of this volume is a computational linguistics problem at its foundation. The records are highly noisy, buried in repetitive legal boilerplate, wildly inconsistent vendor names, and opaque government acronyms. Layering a generic model wrapper over this dataset forces it to process noise as signal, leading directly to hallucinations and the systematic generation of false market data. To solve this, we built a purpose-built end-to-end computational pipeline, outlined in this 7-stage strip. It is engineered specifically to systematically ingest, clean, embed, and reason over the entire federal corpus. Intelligence requires engineering the entire architecture, from the database up to the model, rather than borrowing an external AI and hoping it understands the market. This diagram breaks down the system's architecture, which aggregates all disparate sources into a single 3 terabyte monolithic Postgres database. By unifying relational, vector, and governed data features in one place, the system can reason across different datasets without relying on fragile external joins. Once aggregated, the data moves to the cleanse stage. This extraction pipeline uses statistical methods like Yake and neural extraction like KeyBERT to identify and strip out standard forms and repeated legal jargon before analysis begins. This cleansing process performs 2 jobs at once. While it subtracts noise, the run-to-connect step classifies surviving terms against strict similarity thresholds to build a cohesive keyword-to-record graph. This process maps 4.5 million distinct keywords connected by semantic links. This heavily refined keyword graph becomes the essential backbone of the system, ultimately powering both the search engine and the broader knowledge graph. This flowchart illustrates the embedding layer. Every language surface, from structured records to multi-page documents to specific passage chunks, is mathematically converted and funneled into a single, unified embedding space. To understand the actual semantic relationships between these documents, the system generates over 75 million distinct vectors, mapped across 1,024 dimensions. This allows the computer to measure the conceptual distance between ideas. At the center of this architecture sits GPN-1, an in-house language model specifically trained from the ground up to reason about federal procurement. When a user asks a question, a proprietary retrieval architecture called BERT GraphRag fires. It simultaneously searches the vector space, the keyword graph, and traditional full-text indexes, fusing all those surfaces into a single ranked result set. This fused retrieval acts as a hyper-precise filter, ensuring that only the most relevant is fed directly into GPN-1 to synthesize answers. By pairing a unified vector space with a domain-specialized model, the system achieves a level of rigorous, grounded reasoning that general-purpose AI cannot replicate. While the system answers direct user queries, a second layer of background computation works to identify patterns that aren't visible in individual records. An anomaly detection system deploys 15 distinct mathematical models to continuously monitor the ecosystem. These filters have flagged over 322,000 anomalies to date, trapping hidden walled gardens, sudden collapses in competition, or unexpected purchasing surges as they happen. Crucially, these detections are rooted in explicit, measurable statistical tests, like Markov transition probabilities and chi-squared independence tests, rather than opaque black box AI estimations. This proactive analytical layer produces predictive market signals from raw historical archives. Before any analytical finding reaches a user, it must pass through a final mandatory gatekeeper, the Evidence Integrity Framework, or E3. E3 applies strict intelligence community tradecraft. It uses Bayesian sequential updating to ruthlessly score the statistical confidence of the machine's own claims. The system also utilizes Dempster-Shafer reasoning, visualized here as a confidence interval. This math performs a critical function, explicitly mapping the boundary between known facts and explicitly quantifying what remains genuinely unknown in the data. We started with a chaotic, fragmented ocean of federal records. Through ingestion, semantic cleansing, vector mapping, and rigorous statistical gating, that noise is transformed into a structured, versioned, and fully auditable knowledge graph. This total ownership of the architecture transforms raw public data into mathematically rigorous foresight.